Hi there, I'm Sean Hurley, Autodesk Community Manager and Engagement Manager. You're probably wondering why I'm doing the intro this way. It's because I didn't hit the record button until we were through the intro. So we go right into Phil Eichmiller's questions and answers. This is a really great session. It was a lot of fun. Phil was 4 for 4 on some really deep um, workflows customers had. The first one is about how do you loft between different planes in Fusion 360. So this was really good. I mean, we got really good feedback on this one. So I know you'll be excited and you'll want to attend one of the future events. There'll be another one in June. Um, I'll go through a couple of these slides and then I'll get into the recording of the questions and answers with Phil. So again, welcome. This is the Autodesk Community Conversation with Phil Eichmiller, and I'll be your host. Um, Autodesk Community Conversations are virtual events featuring expert speakers from across the community. The sessions can range from deep dives, tips and tricks, ask me anything style, which is what Phil does here. He takes your questions on how to do something or workflow problems you might have and then answers them. They cover all different Autodesk products as well as all levels, beginner to expert. So we hope you will join us, not just watch the recordings. They're really fun and interactive. This is a community conversation, so it's a conversation, not just a webinar. Um, all right. Safe harbor statements: don't make any purchasing decisions based on any forward-looking statements we might make. Make those purchasing decisions based on the product as it is today. So if we were to talk about possibilities of a future feature, don't make any purchasing decisions based on those until we deliver those in the shipping product. And normally Chris Benner is the host of this series, and he was under the weather this week, so I took over, and that's why I was juggling too many things, hit the record button too late through the intro. So that's why I'm re-recording the intro for you. You don't get to hear Phil in this part, but you will going on through. So um, anyway, I will let you guys get into the recording, and thank you for putting up with me. I live in shame over this inability to hit the record button and intro Phil. So too many things going on. I found out I was going to be the host just a couple hours before the session. So anyway, thank you very much. Hope you'll join the live events. We've got a lot of them. They're a lot of fun. Spread the word. Thank you.
Models there. All right, so what you're experiencing in Inventor, it would be, I can demonstrate this with perhaps a couple boxes. If we need to go more complicated, we will. So let's just do that, and we'll make a cylinder component over here. So we have some slightly different geometry to work with, and make that also a component. So one of the key things, first of all, starting off, is that Fusion does not have different file types. So in Inventor, you're used to having parts and assemblies and stuff like that, right? And so the work you're talking about would take place in an assembly environment. So in Fusion, that requires you to create components. So this is, if you look at some of the iconography here, right, the little stack of boxes, that should be very familiar from Inventor to show you an IAM file. In Fusion, it's just a component that has more than one component in it, right? Compared to, for instance, just a default component that has a single box, which represents the idea that this would be a part. So if I created just a single body here, this would be a single part file. And because I've created components, this is an assembly. Now I say all of that because the key is knowing that in an assembly, things move around. In Inventor, this would be called a flexible subassembly. You would have to right click on it to ensure that it's flexible. In Fusion, it's just flexible by default. Everything is flexible until you give it something that mimics a real world situation. Like, for instance, if I was going to attach this to this, In the real world, this would probably be clamped down somewhere. It would be bolted down. It would be somehow joined to something else. And the thing I would be moving towards it using the joint command in this case would be free to travel over and somehow make some kind of connection to it. Now, the way Fusion handles this freedom of movement is seen here in this capture and revert position. So putting this in inventor terms, if you take and move components in an assembly, you'll see the little invisible Gorilla Glue snot that connects everything up. And when you rebuild that assembly, everything goes right back to where it was. So that's exactly the same thing you're doing right here in Fusion. 100% exactly the same thing, except you don't have to start a move command in order to do it. And revert is as simple as that, or rebuild the assembly. Now, to get to your question, you're having trouble aligning these things. Well, the first thing I might do is, let's say, I'm going to ground this component so it doesn't move around. This could also be jointed to something else. And who knows why this is grounded, but if I don't want it to move, I'm either going to have to ground it or provide a joint to something that says you're stuck here with X amount of degrees of freedom. So this has no degrees of freedom, so it can't move at all because I grounded it. Now, aligning this to this, what you're probably expecting is available actually in Inventor, right? So I take it you don't tend to use the joint system in Inventor, which Fusion basically took from Inventor. It wasn't created for Fusion, but we have, I think, improved upon it just a touch. Maybe if I may be so cheeky as to say so, but so being able to just create a joint where these things join together is that's the easiest way to align it. Now, you mentioned a shaft and a bushing, so it is. Let's see. Let's revert that position. You mentioned a shaft and a bushing, and so what I'm wondering is what is the real relationship between that shaft and bushing? Are they in fact? Do they have a permanent relationship that you could use a joint to express?
Yes, they do.
Okay, so really, maybe it's a matter of learning how. I don't know if I can help you here. There's also I will provide a link to a class that I just did at AU last year, Autodesk University, all about joints, motion, and position. So that's really going to help you here. But in the case of just trying to use a joint here, to make a real parametric relationship, we might pick cylindrical, and let's see, is it going to let me pick stuff? Why does it seem like, oh, I picked cylindrical. This still catches me when I go and make the switch. I forget I got to go back to the position tab in order to define the position. How silly. Okay. So I pick a joint origin on the shaft, and then I pick a joint origin where that shaft might pass through something that's similar to a bushing or something. And you can pick where you want it to start. So in other words, what's your 0, 0, 0 position? You can set that, and you can move it around at this point. So using joints, what you're doing is you're defining the degrees of freedom more than you're constraining. So Inventor says, well, okay, I put a constraint here. In SolidWorks, they're called mates, where you say, well, there's a planar condition here, or there's a cylindrical condition here, and these combination of things make it so that this thing is in the place I want, and it can move in the expected degrees of freedom I want. Fusion, all it does is says, well, hold on, what degrees of freedom do you want? And what is the relative coordinate connection I can make between the two components? And in this case, it's the center of this shaft and the edge of this hole here. Does that help?
That helps a little. How about the rotation of the shaft in this case? Can you control, like, this doesn't have any features on it, but if it did, can you control how one is rotated at some degree to the other part?
Yeah. So I'll put a notch in here, and then this is not at all properly located, so don't expect this is not a key shaft, but it looks a little like one. So I'll do the same thing here and put it in there. And so because this is cylindrical, right, it has the ability to slide up and down and rotate. So I can also set like a relative position. So if it needs to start at minus 45, that's just where it lives. And so you can use the joint alignment to pick that out. So now it moves up and down, and any movement away from that, that 45 degrees is just the starting position of it. Now, if you wanted it to be, if the shaft was, for instance, constrained completely in terms of rotation, you just want it to be at a specific angle, then I would actually go for a slider and put a slider in here that allows me to set it up, give it an angle of rotation, but it'll maintain that angle of rotation, right? So slider has one less degree of freedom than cylindrical does.
Okay.
Now, there's another thing you mentioned, because you did use the term align. Fusion has a powerful move command, but there's something very key you have to watch out for, which is it defaults to bodies. So if you start moving bodies around to position them relative to each other, what you're doing is you're ignoring where these origins are, right? So if I was to move this body, and I'm not paying attention, and okay, I'll just move the body, and blah, 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 I'm cruising along. Notice the origin for the body. Let me turn off this other origin. The origin for the body is not moving along. So this would be like me going out to the machine shop on a Haas mill and just moving things around relative to G0 and going, well, okay, G0 is right here, but I just want to move stuff around. Well, immediately you would see the problem with the CNC setup. And for me personally, I never move bodies unless I absolutely have to. And I have a problem with the fact that it defaults to bodies instead of components. So I think in an assembly like this, you probably want to move components, and in which case you'll get the same sort of capture or revert the position kind of behavior. There's a fancier move command, which is called align. And that's interesting. Align defaults to components. All right. Well, align is just basically a move command, but it's got some special powers. Like it allows you to, so you see the manipulator produces a little square that sort of indicates some direction, but it's also indicating a plane more than anything. And so I'll align, let's say, the bottom of this shaft with, let's say, the midpoint of this. So I can pick the top, the middle, or the bottom. And what I'm going to do is, let me see if I can get it to snap to. I'm going to hold down Control, and there we go. It's going to let me snap to that middle point. So now the shaft is aligned halfway in there. So align is just a super fancy move command with some different things. So maybe that might be of use to you if you just like to get things in place without using a joint. And then maybe you could just use a joint after this, if that's how your mind is thinking about it. I would use the align command on components, so you're not moving it away from its origin, and then just capture that position. So now it's here. Now, of course, I can move it all around, but that's its new home position because I captured that. And if I wanted to use a joint, right now I could use what's called an as-built joint, and that lets you take components that are already relative to each other and define the motion or lack of motion between them. So it's another extension of that joint. That's kind of why I said that we had improved upon Inventor just a little bit. Sean, I think Inventor would super benefit from getting an as-built joint in there, but because you can do multi-body to assembly workflows in Inventor, and as-built joints would just be perfect for that. Anyway, so does that help at all, Space? Even more so.
It does. How I made parts was I made individual parts in Fusion 360 and then brought them in one at a time into an assembly. I call it an assembly model.
Yep.
Does this system work with parts like that?
Yeah, absolutely. So Fusion is rather flexible in that way. So if you look, let's see if all I have is really simple examples here. This is some of my class. I teach at Portland Community College. So Yeah, I mean, just a completely bottom up type of thing where you might say, let me just do it this way. So I would start a new design, and I might say, this is the assembly. So this is the assembly, and I need to go start putting. I'll find some realistic looking parts. I need to start putting some stuff into this assembly, right? So I might go find my mailbox and insert it into this design. So uh, all this is just taking Fusion and using it like you would any other. Why is the grid on? I don't like grid. Turn off grid. There we go. Using it like you would Inventor or even SolidWorks, right? First, you set up what would be an assembly file, and then you bring things in. Inventor lets you edit those things in place by double clicking on them. In Fusion, it's a little different. Let me bring in the mailbox shell. So just kind of show you some, like, how would I, so these things were, these were made all separately, weren't they? So I should be able to get this done. Now, of course, I've picked the absolute hardest thing to assemble, which is sheet metal. Because all the control points are like, they're either in midair or they're where, right? But so maybe I won't quite go that far down this adventure of a rabbit hole here. But so when you do what's called edit in place, which is click the little pencil, notice that it puts a blue border on, and it says, oh, you can finish edit in place if you want to. And you should have access to almost every command you would want to. There are a couple of limitations just because of how Fusion does parametric compute. So if you run into limitations while in edit in place, it's probably expected. But there's very few these days. We've actually worked really hard to eliminate those. But now I'm working on this, and so similar to Inventor, you would see the other parts are grayed out. The part I'm working on is front and center, and I can do whatever I want. I can poke holes in it and whatnot. And then when I'm finished, you go back out, and now you're looking at basically that top level, right? So all the features that I edited were contained here, and the only thing that's in this top level assembly is a list of linked components that's filling up my timeline down at the bottom.
Phil?
Yeah.
George had a question related to this right before you got into this rabbit hole. Why would you use a joint with 0 degrees of freedom as opposed to just an align as you showed?
Good idea. Well, I mean, good question. Okay, so a rigid joint, which is a joint with 0 degrees of freedom, that's what you do when parts are stuck together. So if I put a screw into a hole, right, that screw is not rotating. There's 0 degrees of freedom there. So I would put the screw in the hole with a rigid joint so that if that part moves around, it takes the screw with it, as if they're glued together, or the screw is actually just wedged in there and there's compressive forces on those threads that keep it in place. Does that help, George?
Yep.
Yeah. I mean, joints are for when there's motion, right? So one of the things that's key here, and I think maybe this gets at your question, if you design things that have no motion at all, then you don't need to use joints, right? There's another caveat to that. If you're editing these parts and they change size and you expect things to move around relative to each other, so if the mailbox got taller and the flag needs to go with the mailbox in this case, let me just open up the mailbox so I can talk about a real mailbox. Yeah, so most of the stuff, this moves and this moves, right? So obviously I need joints there, but what if this mailbox got taller? Or let's say it got taller, the door would get taller, and then the rigid joint between this knob and the door, that would be what keeps the knob in position around the hole that it's positioned with, right? So absolutely joints are required in this case, in case I make either motion by opening the door or possibly a parametric edit where that hole that mounts the knob would move. So to make that connection together, you have to have a joint. A line is just, like I said, it's a fancy move command, and it's a great way to put stuff right where it needs to be. But if there's motion or editing, parametric editing, you need joints. That's a good question, though. I like that. It's one of the tougher concepts to teach because not everybody, when I'm teaching, not everybody has enough experience to understand. Like, oh yeah, they can't conceptualize. Sometimes you make machinery that does not need joints. It's a possible thing.
Are we ready for a new question?
Yeah, let's go for it.
This is also from George. He had a question about sheet metal space. Can you unfold a design and cut like a solid body, then refold?
Yeah, absolutely. So let's first, before I break my mailbox, I'm going to close this without saving because I made some changes I don't want to carry forward. Let's use this base as an example. So I'm going to right click on here and I'm just going to open this thing. Just get it open in a new file, or not a new file, I should say, in its own document. All right, so in the sheet metal workspace, you have cool stuff like all these commands, and where's the one I'm looking for? Not bend. Sometimes I'm like, okay, create, modify, fold, like there's really a fine line mentally, like where these things go. I want to put unfold on the toolbar. So here's unfold. What unfold allows you to do is something that's pretty common in sheet metal, which is you need to sort of model things based on like, how is this being fabricated, right? There's sheet metal is one of those unique places where everything you're designing is built around how it's fabricated. Normally you might say, I don't know, is this 2-axis or 3-axis CNC? Is this injection molding? Like all of those questions are sort of in your normal design process, but in sheet metal, you're like, this is going on a punch and I'm going to be using a 1/4 inch by 2 inch shear to make this slot, right? So that's the background on this. But I just use the unfold command, right, which puts unfold down in the timeline. So this is a parametric event. Now what I'm going to do is I'm going to go ahead and sketch out where one of my my punching tools would go. We're in millimeters here, so I'm going to make this 10 millimeters by, let's say, 100. And I'll just position this thing right on the center, hold down Shift, pick that midpoint, make it horizontal to this. Anyone coming from Inventor, you might have noticed we have one horizontal vertical command. That's on purpose and it works way better. I wish Inventor would adopt that. Now let's see, hold on. I'll just drag this into place. So somehow this is, maybe this, I'm trying to think of, I'm contriving some design criteria here. Let's say this top of this slot has to be 150 millimeters from that edge for some reason. And the people that run the press, or the punch turret, the turret punch, excuse me, down in the machine shop, they're like, you have to use this 100 by 10 millimeter shear every time you do this slot. And you're like, okay, well, I've got all of my design criteria involved here, so I can finish the sketch. I can please the people down in the shop. I can also put the notch in that I wanted to put into my sheet metal. It's in the flat pattern now, precisely matches what the shop can do because it's been flattened, and now I can refold. So that's the magic of unfold and refold right there. But it is the fold command that's doing this. It is not flat pattern whatsoever. Anyway, so imagine how hard it would be to design this thing to be perfectly 100 millimeters long without being able to unfold it. That would be, you'd have to go through, do all the math and figure out exactly where this edge should be and this edge should be. Well, I guess this one is always going to be that distance to up there, but where does this one end up? Who knows, right? You got to have that unfolded. Let me know if you want to know the difference between unfold and flat pattern, because that's another thing that comes into play here.
That's an affirmative. He says he does.
Okay. Well, so the reason you can edit a flat pattern, right? Does this have a flat pattern? Let's edit this. The reason you can edit a flat pattern is because there needs to be that flexibility there, right? So all of the sheet metal parts I used to make would either be cut on a laser or made on a turret punch. And those machines sat side by side. And so, like the turret punch is going to get real picky about how do you make these bend reliefs, right? The laser didn't really like square corners. So now I've got a problem. I want to prototype this part on the laser, but it's going to put little burnouts in the corners there, and I need to make the bend reliefs different. But I really want this to be my production piece where all the rectangular shears come in and make all these shapes, right? So how do I get around that? Well, one of the things I could do is I could just, I'll use the whole command here, maybe or maybe not. I'll sketch it on. So maybe I need to just, for this instance, go ahead and put manual. I'm just making up a size here, but I'll manually create the relief that will make the laser the happiest, right? So now I can go cut this thing, run it through my contouring and get the laser happy with it, and finish the flat pattern. And you'll notice that change is not carried over to the model. And you think, well, I thought I just changed the flat pattern. Yeah, you changed the flat pattern, which is in fact another model. It's not this model. It is the model that I'm going to send to manufacturing, and it has the details that are taken. They're extracted from the folded model and interpreted to be this flat pattern. And I now have control where I can make little changes if I want to. I really don't see editing flat patterns as a super major workflow. This is like actually a corner case, but it's the kind of thing that when you got to do it, you got to do it. So really just kind of put it out of your mind, right? I don't need to edit the flat pattern. I probably need to just unfold a couple faces and put in something like this slot where it needs to be. Does that help? I hope.
Yep.
Cool. Yeah, it's I just had to explain this in my class too, and it was it's there's so many of these ideas are like, it's until you start working with it, it's really like the practice that makes perfect, right? Because unfold and flat pattern, they seem so alike. It's not really super clear. I mean, let's see what the tooltip says. Okay, that makes sense. Let's see what this says. Yeah, see, like right here, could the tooltip say something like, it's possible to edit the flat pattern, but those edits are carried only by the flat pattern, or something to clarify this. That might help. I should probably suggest it.
All right, let's take the next question we had from Josh.
Awesome.
Could you demonstrate how to guide a loft of two sketches that are on totally different planes?
Whoosh. Okay, well, first of all, lofting between sketches that are on a single plane is difficult at best. Anyway, most lofts are between two different planes. But this is getting into an area where I'm less of a dominant force. But let's try this. So the first thing I want to do is I want to create the origin for my loft. Where did my sketch palette go? There we are. I'll put in a rectangle that is 3 by 2. And hopefully this works. Let's see. Now I want to loft between that and, let's say, an offset plane, but I also want I want to have it be at some sort of angle. So let's see, how would I get that to happen here? Well, I could just put in a construction sketch. That'll be easy enough. So I'm going to put in a construction line on this sketch here to serve as an axis for another plane, and then put this at a slight angle. go ahead and make a sketch on it. Turn off that axis sketch. And let's make another rectangle here. And we'll make this 2 inches by 1 inch. So now we have definitely the need to loft in order to get these two things to talk to each other. Now, lofting between here and here, right? That's pretty straightforward. And what the only control you have is, like, for instance, is direction. So you can kind of start to say, well, look, when this shape approaches this face, what angle is this thing going when it gets there? And that's what direction means. Lets you pick that sort of thing. Now it's set to guide type rails or center line, but notice there's no rails defined. We can edit the takeoff weight. So if we made this 0.5, that will also sort of affect how much influence this direction has relative to where it's starting from. All right, so let's try to put in some rails. I'm going to do this the easy, hacky way, and I'm going to put a sketch in right here that perfectly intersects these two things. And I'm using the S key. So when you see this little shortcut box up here, if you type the letter S, this is a great way to add things. You can search for commands and stuff, so forth. I'm going to intersect this and this. And just for your information, that's down here on this menu, which is a pain to get to. So that's why I keep that on my shortcuts, right under my hand, under my ring finger on my left hand. The S key always lives. All right, so I've got these two sketches projected in there. I'll put in, let's say, just an arc. Let's put in a gentle arc to kind of give it a nice bowing shape. Finish the sketch. And then when we're lofting, now we can use that. We can use that rail. So I'll pick the rail, and now we have a much different. So this is really similar to that direction, the way it looks when you pick direction. But notice how it's nice and smooth. It's not bothered with takeoff and sort of curving and waving as it comes in and out of the shapes. It's just very literally following that rail. So you can add any number of rails, and usually people are probably using 3D sketches to do that. Obviously, if I wanted rails on all four sides of this, I just keep adding rails by using the plus sign here and picking more rails. So the key to a rail is that the rail has to intersect the sketch, and you have to project them together. One of the things that lets you do, for instance, is if I change this down to, let's say, 0.5, that position of that rail, should update. I guess let's go. What did I do wrong here? Let's see. That's interesting. How about if I always love it finding these sorts of things in the middle of a demonstration. Okay. I wonder if it just needs a compute. Yep. Okay, well, I found a case where you have to use compute all in order to get the rail to update. That doesn't seem like that should have to happen. It should have did it by itself. But that's the point of making these connections, right? When I made this rail sketch, those things are parametric points that this arc is attached to, and for some reason I had to kick it unnaturally in order to get that to update. But you can pick them in any order. Just use the selection tools. Well, now that's
just making it a manual compute so that if you had a lot of operations to do, it wasn't wasting performance doing all the computes at each step you did.
Yeah, but it should, though. That's the thing, is that it should just do that compute. So I don't know what's going on there. I hesitate to call it a bug. It seems like it shouldn't have to do that. So I'll follow up with that as soon as we're done here. Did that help, by the way?
All right, you got it. You're
so,
3 for 3.
All right. So there is So I have to stop in just a second and put some links in. So don't go away until you get some links from me. There's a forum post about lofting that Jeff Strader did. That is like, it is like the manual for how to do lofting and rails and stuff like that. And I've got the link handy, so I'm going to have to grab that. Also, for the joints questions, there's a link to an AU class. It's an hour-long class with a 63-page, I'm going to call it a manual, because it is a manual for joints and motion in Fusion 360. So I think all of these things are great. You can watch them as you need, or just maybe if you're more of a read the book kind of person, you can just read the handouts that are attached.
And Phil, we can just put those in the comments on the event page as well, and then they're there for everybody who watches and stumbles across it.
So grab them when I do that. Let's see, Brian. I'm just noticing there's another question. Is there one ahead of Brian?
There is. George let's hit George first. What is best practice for fully constraining a sketch? I often find myself in the weeds when I make changes to constraints.
Okay. Let's talk about the happy face sketch. This is the way I teach constraints versus dimensions. There is no one answer to this, right? But this will hopefully frame it for you. Is he unhappy or happy? Let's make him happy. Or make it happy, rather. We don't need to gender this thing. All right, so nothing has a dimension or a constraint here, with the exception that this circle is pinned to the origin. So rule number one when constraining a sketch, attach something, the main thing, to the model origin in the sketch, right? It has to be attached there somehow, either via dimensions or constraints. Otherwise, the sketch just floats around anyway. So you haven't constrained a thing unless you've got something attached to the origin. So step one in our smiley face is, yep, we're already attached to the origin. Step two, your design intent is probably mixed up between dimensions and constraints, but you know that constraints are more powerful than dimensions, because the constraints in a sketch, there's no numbers needed. These are relationships. So think about all the relationships in your sketch that are just the ground truth of this sketch. What is the most simple thing you can say about this? Well, starting with a smiley face, I'd say, I don't know, a proper smiley face has eyeballs that are the same size, right? So that's never going to change in my design. So I made these things equal to each other. I don't know what size they are right now, but I know they're equal. So that helps. Another thing I might do is say, well, the smile is always going to be symmetrical. So there's this idea of making a horizontal vertical relationship here. And you can see it's still kind of dragging things around is really kind of, whoa, I don't know. I feel like I'm on ice. You know, I'm like, oh, there's not enough control here. I don't have, so I need more control, but at least the ends of the smile are, they're symmetrical. Got a nice happy face going here. Let's do the same thing for the eyes, right? We want those to be sat across from each other like that. And I'm going to make a call here. I want the smile to be concentric with the outer face for my smiley face. So I'm going to use coincident and put that the center, that's the center of the arc, coincident with the center of the outer face. So now everything sort of starts to behave a little bit better, I think. Okay. Where you go from here is up to you. At some point we have to start. Why does this happen every time I'm doing this live event? Sean, remind me to turn my phone off, because the one phone call a month I get, and I mean I get one phone call a month, apparently happens during this event.
It's probably Chris.
Unbelievable. Yeah. No, it was my medical provider just had to reach out for some reason. So God knows I'm missing out on an appointment or something. That's okay. This is way more important. So there really isn't more constraints we can add here. So we've sort of exhausted our ability to install what we consider our design intent. And now we have to start saying, well, we have to be more prescriptive here. So some numbers and sizes are going to come into play. I'm going to make this a construction line, for instance. So now we can use this to get the eyes centered over the nose, so to speak. I'm going to hold down Shift, pick that midpoint. I'm using horizontal vertical to arrange that midpoint vertical of this. So there we go. Now, so you can see that's still in the constraint mode, but I had to add some more tools like this construction geometry. Now the rest of it's going to be, what size do you want it to be? All right, so 6 inches here. Now, of course, if you were completely off scale, this could get a little weird, but with a smiley face, it's not hard to stay on track. There we go. And so what is missing? All right, does anybody want to guess what's missing? Oh yeah, we don't know the width of the eyes. Is it a minion or is it like, something else? Is it somebody with a big brain, right? Someone super smart like all of you? Who knows? So we'll go ahead and by dragging things around. So this is the last method, right? The last method is looking at the sketch icon. It doesn't have a lock on it yet. Some stuff is blue. The blue stuff you can drag around. In this case, it's doing a pretty good job of letting me drag it from almost anywhere I could grab this thing. So then now it's just a matter of maybe adding a little more control here. We're going to give it a slightly big brain and slightly more focused gaze. And now why isn't this say it's? Oh, I know why it's not locked. Here's a pro tip. See these little endpoints here? They're white. So a lot of people go, hey, all of the lines changed color in my sketch. They turned black. So how come it's not constrained? And you look at it, and often what you find is, well, yeah, all the lines are black, but there's these white endpoints. Those indicate they're not constrained. So we need one more dimension, and this would be, if I had a named parameter, I would say this is the happiness factor, and I'm going to give this thing a really high happiness factor. There we go. And we have a lock on the sketch. And the thing I really like about this is that, because I've taught all the methods in Inventor, and I used to teach everyone to look for all the little telltales, which there's like 2 more things that Inventor does. Like it'll give you a readout about how many constraints are still needed and so forth. I think that this helps me teach students more about capturing their design intent instead of just getting shapes on the screen because they don't know any better. And so they're like, well, it's got to be this big and it's got to be this big. And they're not thinking, right? Whereas like, I want you to learn how to think, and like, well, there's stuff I want out of this design that's got to be true. And you get that into your sketch first. Numbers might be part of that, right? We might have started with the overall size of the face here just to frame everything. So it's, like I said, it's not just one way, right? But start off by rules. Rules are more powerful than numbers. Numbers are more brittle. So by the time you get around to applying numbers, then all of your geometric rules are really helping those numbers make more sense.
That is awesome, Phil.
Yeah, I've only been teaching for 14 years now.
Lynn said this is the best constraint description tips I've ever seen. The community college teaching really benefits you and us all. So awesome. Thank you, Lynn, for saying that.
That's a great compliment. I appreciate that.
And George also on those points. So yeah.
That's awesome. Well, before we run out of time, I do want to go find that. So let's see if I can't get this to open up.
We do have one more question, but you go and look for those. We'll be fine.
Yeah. All right. What's the question while I'm doing this?
It is, it's from Brian. Is the loft the best way to model as cast surfaces, or is there a better way?
Lofting, this is a little hard for me to answer because I'll go ahead and say that I was in sheet metal and extrusions and things like that, and I know a lot about this stuff. You saw me struggling just a tiny bit with lofting. I think lofting would help you get to a defined parting line better than a lot of things, right? Like a lot of times when you're modeling, what's going on is you're thinking about if you're going to be casting anything, right? you're thinking about parting lines, right? So if I'm doing this extrude, oops, of course it picked it for me automatically. I'll do 2 sides, bring this one up, bring this one down, and I'm going to add a taper angle. So -2 there and -2 here, right? So just by doing this way, this is just a simple extrude, right? But if you're doing this workflow, you're already thinking, well, that's my parting line, right? So if you know where that parting line is and you can define it with, and I don't, where's the loft? Did I retain that or did I blow it out of the water? Oh, here it is. So thinking about it this way, like this, if this sketch represented where that rail is, represented the parting line of this lofted part, then yeah, absolutely, it works great. What I would wind up doing is changing these things to build in that draft right here on these profiles. So your sketch profiles get more complex, but you can build that parting line right into your loft if you need to. Hopefully that helps. If I'm missing something key, let me know. All right, where is the chat? All right, so this is the chat class. Now unfortunately, there's no recording because when we did this, some glitch happened, and so all you get is a 104-page handout authored by Jeff Strader that'll tell you everything you want to know about sketching. Some of the user interface is a little bit older, so your mileage is going to vary a little bit on some of the colors and descriptions of things in there, but all of the principles are rock solid and is wisdom of the ages there. Now where is the, I also promised joints and motion. Now this does have a recording and featuring yours truly and Jeff Strader. Jeff Strader is one of our top architects. He was an inventor architect. So me and him were on opposite sides of the screen when I was a customer. When I joined Fusion, we were on opposite sides of the cubicle. And I can't say enough good stuff about knowing Jeff. We do all of our Autodesk University classes together. It's our British friends say we're like chalk and cheese, and in the best possible way.
Yeah, you guys are good, and I got to see both of you in Atlanta.
Yeah, we did a class on crashing. That's my passion in development. So, teaching other developers what I think about crashing.
Awesome. Well, I've captured those 2 links. I'll put those in the comments for us, Phil. But that's good. That's good stuff.
Yeah.
If we have no more questions, we will wrap it up then. Are you good? Everybody happy? I mean, look at that. Nobody stumped you today. They put you to some challenging areas, but
well, just don't ask about generative design because I don't have the time or patience for it. And it's just not. I mean, really, a lot of what I know is like this is in my wheelhouse because I test this stuff all the time too. And so some other development teams do generative electronics. It's the same way. I could barely find my way around in there. But I know what all of that stuff is. It's so funny. I did that for years and years, but I worked with an electrical engineer. So I know what I'm looking at when I'm looking at electronics, but making it happen in Fusion, it's like I've got mittens on trying to do surgery. It doesn't work very well.
You had some good comments in there. George is asking if your community college class is available online. He'd like to take it, but lives in Virginia.
Sweet. Yeah, we're starting one up in June. It'll meet twice a week for 5.5 weeks. Hang on a second. Let me find the link for that, and you're absolutely welcome. Now, I don't know what it's going to do for out-of-state tuition and so forth, but it's only a 3-credit class, and I'd love to have you. So let me see if I can't find that class schedule.
While you're doing that, Brian made a funny comment. What's the easiest way to crash Fusion 360? Don't tell him. Don't tell him.
There's a text command.
Yeah. And then Lynn said,
why do you need to crash it? I'm just curious.
Oh, just for fun, I'm sure. I mean, yeah, we used to do that with the AutoCAD. Yeah, definitely. Yeah, Brian's for fun. Lynn also said this was very much worth their time. Thanks for doing this sort of thing for us. So it's always nice to get that kind of acknowledgement that it helped somebody. So thank you for that, Lynn.
All right, so I just put that in there. If you, why doesn't it have a link to the information page for that class? Let me dig that up, because the information page has more stuff. That's the class schedule, but I need more information. Why is
that's good? We can put it in the comments, Phil.
Yeah, there's a way. If you look up the CRN number, which is this, somehow on the PCC side, it's baffling my brain right now. But that page will show all kinds of stuff, like this is how the class works. Here's how we meet. Here's how you sign up. Here's all the stuff. I put all that information into a details page for that that particular class. So it's in there.
All right, let me wrap it up. Share my screen. Hopefully I get the right one. I got to relaunch PowerPoint. It does it to me every time.
Yeah, and everyone, be sure to come back. If you got more questions between now and the next time, come on back, bring a friend, tell everybody you know. I'll take every question I can find, except for generative and electronics. If we get a bunch of questions like that, I'm going to have to bring a friend.
Oh, see, we don't want that. Let's see, I'm trying to share my screen too. Tell me if you see my PowerPoint. Do you see my PowerPoint?
Looks lovely.
Yeah, you see? Okay, I just need to make sure you're doing that, not my email. All right.
We don't want to see that.
No, that's no fun. All right, I'm going to close it up and wrap it up and thank Phil. Phil, thank you. This was fun. It was informative. You were 0 for 3 until we hit the PCC event page. They stumped you. But anyway, I'm gonna post some links into the event page. There'll be helpful links going to the community, the user group, the Autodesk Group Network, which is our Autodesk industry-focused communities, where you can help colleagues and solve business challenges together. The Autodesk Forum, the Twitter account. We have blogs, so we have the community blog as well. We have a blog that is customers for customers, so community for community. And there is some awesome Inventor, and we're hoping to get some more Fusion in there too. So customers that want to blog on Fusion, let me know, contact me. We'll make you an author. It's a great way to share your knowledge and give back to the community. At the end of this, you'll get a little link to give a survey. We would be really happy if you just kind of let us know how everything went. And if there's anything that we can improve, it helps us kind of shape this program as we go forward. So I want to thank you for joining us, and I hope that you'll go to the Community Conversation page and sign up for the future events that align with what you're looking for in information. There's several Fusion 360 ones, even right down to Fusion 360 electronics, and we just had one on machining. So you can attend the live ones or watch the recordings. So thank you very much, everybody. Wow,
yeah, thanks a lot. This was a lot of fun.
I'll put some of these links in here while we're jumping out.
Yep. And I promise I will figure out how to get to the class details. Here is the class details page. All right. My goodness.
All right, here's the last of my links. And I'll send everybody on the way. Do you have a link coming?
Yeah, give me just 1 second here.
Absolutely.
Beauty. This is it right here.
Okay, and I'm going to give one more link. This last link is for those that would like to be an author on Fusion 360 on the Voices blog. So just in case. All right, paste your link in there, Phil, and we'll let everybody get back to their, what is it? It's Wednesday.
Yeah. Oh, we're 1 minute over. We're so much excellence. We've flowed over into the next.
Oh, you
hour.
have no idea. I missed grabbing the first 2 minutes of the session. I didn't hit the record because I was trying to find PowerPoint. So I will fix that in post, as they say.
All right.
All right. Thank you very much, everybody, for attending. And thanks again, Phil.
Yeah, no problem. Really like doing this.
Yeah, we appreciate it. It was fun. All right.
Talk soon. Bye-bye.